Today we are going to discuss very important topics in TRB. Okay, that is parallel reaction and consecutive reaction and reversible reaction and followed by enzyme catalyst mechanism. And before going to enter to the topic, I will cover second order reaction. That is very important. Okay, we already discussed first order, G order reaction. Okay, let's start the please note second order reaction. I will give only the important formulas only. Please note second order reaction. Second order reactions. Okay. Now see. Okay. Now what is the differential form of second order reaction? Please note. First differential form. Differential form. That is minus dA by dt. dA by dt that equal to K into A minus X power 2. Okay. These two represent what? Second order reaction. Okay. Second order reaction. Okay. Now generally we can write dx by dt. What dx by dt now? The change in concentration with respect to time. That is called rate, right? That equal to K into A minus X whole square. Now what is K? That is nothing but what? Rate constant. Rate constant. Some people call specific rate. This is very important sentence. Okay, specific rate. Both are same. They will confuse the new name. What is rate constant? Other name? Specific rate. Okay, mention please note. Now second one, integrated form. What is the integrated first order reaction? That is log. Okay, K is equal to 1 by T into log of A by A minus X. Right. Similar way, I am going to write the second order reaction for the integrated form. Please note. It's integral rate equation. Integral rate equation. Now what is the formula? Please note. For nothing but that is K is equal to 1 by T into 1 by AT minus 1 by A naught. Please note. Now what is A naught? It's an initial concentration, right? It's an initial concentration. Now what is AT? The concentration at times equal to at T is equal to given time. Okay, right? Given time. The concentration of reactant at a given time. This given time. Okay. Okay. Now what is AT? What is AT? Nothing but A minus X. Okay. This A minus X. Okay. This one we discuss in first order reaction, right? Okay. Now this is a formula. This is a formula integral rate equation. Is a very important formula for numerical point of view. Okay. Next important. What is the unit of second order? Anyone tell me? What is the unit of second order reaction? What is the unit of second order reaction? Rate constant. Rate constant. Unit of rate constant. Okay. Please note. That is mole inverse liter second inverse. Okay. What is the formula? What is the unit of rate constant second order reaction? Mole inverse liter and second inverse. Okay. And third most important point, that is half life of second order reaction. Half life. That is called T off, right? It means what? T off. It means T 50%. Okay, T 50%. Okay. Write the formula, very important. Listen, what is general formula for T off? The T off 1 by n minus 1 is general form. Now what is n equal to here? For n equal to second 2. Now why 2? What is n represent order? The second order reaction. Therefore n is equal to 2. Now just apply the formula, we can find out. Okay. Now what is the formula? Please note the T off for second order reaction, that is equal to 1 by A K2. This is important. This is very important. Now this formula very important. Please note. What is first order reaction T of it? The T of 0.693 by K. This is first order reaction. This is first order reaction. Okay. What about zero order reaction? For please mute your mic. For zero order reaction, T of that equal to A by 2k naught. This is for zero order reaction. This is a zero order reaction. This is for this second order reaction. So listen, now see the relations. Now see the relation. The first order reaction, okay. In case of first order reaction, the half-life period independent of initial concentration. You got the point, right? Because you see the equation, what is formula? 0.693 by K. In this equation, there is no concentration term, right? Therefore, the first order reaction, the T of half-life, independent of the concentration. What was zero order reaction? Directly proportional, okay? Because T of is equal to A by 2K now, okay? For zero order reaction, directly proportional. First order reaction independent. For second order reaction inversely proportional. Okay, these three relation very important. The most probably the direct question will ask from this topic. Okay, please very important. Please note. Okay, zero order reaction directly proportional. First order reaction independent. Second order reaction only inversely proportional. Okay, please note. Now, do you remember, right? I discussed in first order reaction. Okay. T 99.9%, that equal to 10 times of T of, right? Note. This I discussed first order reaction. This is very important relation. Okay. What relation I discussed? This is for first order reaction. Okay. First order reaction. This we already discussed this one. What we discussed? T 99.9%, that equal to 10 times of T of, right? Yes or no? Similarly, the T 70%. T 70% is equal to 2 times of T of. Yes or no? Similarly, the T 87.5%, that equal to 3 times of T of. Okay. This is for first order. Okay. Similar way, I am going to discuss for second order reaction. Okay. Now, this is very important. Please. This is very important. Please note. Okay. What we discussed first order, the same approach, I am going to apply for second order reaction. I am going to derive the relation. I give the direct formula for second order reaction. Please know the formula. Okay. Now, for second order reaction, okay, what is the formula? Please note. Very important formula. Please note. That is T x percentage by T y percentage, that equal to x percentage by 100 minus x, 100 minus x, okay, divided by y percentage by 100 minus y. This formula for which? This formula for second order reaction. This is second order reaction. Okay, simple now. Listen. Now T 70%, that equal to how much time of T of? How much time of T of? Now let's consider x equal to 75 and y is equal to 25. Sorry, y is equal to 50 now. T of 50. Just apply this formula. Now what we are going to get? Is T 75%, that by T 50%, that equal to, okay, 70 by 100 minus 75 divided by 50 by 100 minus 50. Yes or no? What is the answer? 75 by 15 by 50 by 50. Cancel, right? What is 75 by 15? Third or 3, yeah? Therefore, the T 75% by T 50%, that equal to 3. Now, what is final conclusion? Therefore, finally, the T 70% of second order reaction, that equal to the 3 times of the TF of second order reaction. Okay, this is a relation. Okay, you see, right, how we approach this question. Okay, whenever they ask a relation in second order reaction, we can approach this concept. This is important formula to derive what? The relation between the two time. Okay, I give the direct formula. Okay, for T 70 we discussed now. Similarly, I will give the 3 values. Please note. These are previous questions value. Okay, please note T 75%, that equal to 3 times of T of. Similarly, the T 87.5%, that equal to 7 times of T of. Okay. Similarly, T 66.6%, that equal to 2 times of T of. Okay. Now this is very important. This is for which order reaction? This is for second order reaction. Very important. Second order reaction. Okay. Important, please note down. Important, please note. Okay, now I discuss some examples. Okay, please note. Examples of second order reaction. Second order reaction. Very, very important example. Please note. Okay, base catalyst. Very, very important. This is very, very important. Okay, I think 3 days before one ma'am post a question in our group. Okay, what the question now? The example of I think example of second or first reaction. Okay, they given the 4 option. I am going to discuss that one. Please note. First example, base catalyst. Okay, base catalyst ester hydrolysis. Base catalyst base. Okay, OH minus base catalyst ester hydrolysis. This is a second order reaction. Okay, note. Note. That is acid catalyst. As very, very important point. Acid catalyst ester hydrolysis, nothing but pseudo first order reaction. Please note. This is a basic example. Please, okay, the common example. Okay, most of us they will ask this examples. Please note. Base catalyst ester hydrolysis is a second order reaction. This is a second order reaction. Second order reaction. That is acid catalyst is a pseudo first order. Okay, this is very important. Please note. The second order is pseudo first order. Okay. Second example, simple example. That is decomposition of acetaldehyde CH3 CHO to gives CH4 plus CO. Then very important. Okay, S2O4 S2OA2 minus plus 2I minus to gives 2SO4 2 minus plus I2. Okay, now these 3 important example for what? Second reaction. Okay, listen, my graphic representation I will discuss. Okay, with the comparison. Okay, now I don't going to discuss a graphic representation or order of reaction. I will discuss all the graphic representation using the formulas at the end of the class, not today. Okay, at the end of the chemical kinetics lesson. Okay, now see, now going to give the general formula for all. Suppose, okay, suppose in exam they ask a third order reaction. Okay, how to derive the formula that I'm going to teach for general equation for what? All the order of reaction. That is called nth order reaction. Okay, please note. Nth order reaction. This apply for all the order of reaction. Nth order. Please note. Nth order reaction. Okay. Now what is the formula? Simple. Now differential formula you know, that is rate that equal to K into A power N. Otherwise you can write K into A minus X power N. Okay, what is N? You know what is N? Order of reaction, right? Now second, this is very important. This is integral. Please know this is integral rate law. This is very important. Okay, what is the formula? That is K is equal to 1 by N minus 1 T. That equal to 1 by, that is AT N minus 1 minus 1 by A naught N minus 1. Now see, this formula, okay, for all the reaction, for all order reaction except first order. Okay, you don't apply for this equation first order. Okay, first order reaction. Other than first order reaction, we can apply for all order reaction. Okay, other important things, this only for A gives B. A gives B. Okay, not for A plus B to gives B. Okay, only one reactant can convert to the product. This concept you have to apply. Okay, for example, they give 2 reactant A plus B. He convert to B, convert to C now, convert to product now. That type of reaction you cannot derive the for assume. Okay, for assume A plus B to gives a product. Okay, it is a second order reaction. write the formula, you don't apply this formula. Okay, this formula only for only one substrate involving the reaction involving only one substrate, one reactant molecule. Okay, that case we can apply this formula. Okay, suppose they give A plus B, now there's a different formula. Most probable they don't ask that question. Okay, please, very important. Okay, now what about the offline? I discussed already offline, right? That please T off. That's why you know very well the T of 1 by A naught power n minus this important piece. This important piece. Okay, TF. The general for the whole order reaction. Okay. By using this TF formula, we can tell what the either T of the direct proportional concentration or inverse proportional concentration or independent. Okay. That theory based question we can explain using simple the T of relation. Okay. This is very important, please. Okay, now this about the second order reaction. Okay, next I am going to discuss very important about complex reaction. Okay, some case they given the complex reaction, they will tell the derive the equation how to derive the rate law for the complex reaction. Okay, that time we have to apply SSA. What is SSA? Steady state approximation. Okay, that is advanced topic, very important for GATE and CSL level. TRB, sometime the TRB exam they will ask, right? Please note. Now complex reactions. For complex reaction. Please. Okay. Now what is complex reaction? What is a complex reaction? The reaction, the reaction which are completed, in more than one step. Simple definition, na? More than one step. Okay. Second important, please. Second point. Okay. Each steps of a complex reaction is an elementary step. Okay. But this type of point, they will ask in theory question. Okay. Please, what is the first point? For the reaction which are completed in the more than one step. What is the second point? Each steps of complex reaction is a elementary reactions. Is a elementary. Now, what is elementary reaction? Single step elementary reaction. Okay. I give the basic examples. Okay. Now see, formation NOCl. The reaction between NO plus Br2, that is NO plus Br2 two times to form 2NO. Okay. Now generally we are looking at the equation. Is only one step now. Yes or no? NO plus Br2 to use NOCl. Okay. Sorry, NOBr, right? NOBr. Generally we are looking at the equation. It's only one step, right? How they are telling complex? Listen, how they are telling complex? This is overall reaction. This is a overall reaction only. Okay. Now this reaction involving the multiple step. That is called what? Elementary steps. You got the point. அப்போ கொஸ்டின்ல வந்து ஒரு ரியாக்ஷன் கொடுத்தாங்க அப்படின்னா அந்த கொஸ்டின்ல வந்து அவங்க மென்ஷன் பண்ணியிருந்தா மட்டும் தான் எலிமெண்டரி. ஓகே, ஃபார் எக்ஸாம்பிள் this reaction is elementary அப்படி கொஸ்டின்ல கொடுத்திருந்தாங்கன்னா that is elementary reaction. அப்படி அவங்க கொஸ்டின்ல மென்ஷனே பண்ணல அப்படின்னா that is surely 200% damn sure that reaction should be complex reaction. You got the point. அப்ப எக்ஸாம்பிள் அவங்க மென்ஷன் பண்ணியிருந்தா மட்டும் தான் எலிமெண்டரி. அந்த வார்த்தை யூஸ் பண்ணாம இருந்தாங்க அப்படின்னா அந்த ரியாக்ஷன் காம்ப்ளெக்ஸ் ரியாக்ஷன் தான். Therefore all the complex reaction containing the many number of elementary steps. Now for this reaction, what are the elementary steps I am going to discuss? See, step 1. And the step now, that is NO plus Br2, that is rate constant K1, that is NOBr. They given the first steps. They give the process. Okay. Now step 2. This is NOBr2 to gives NOBr2 plus NO that is K2. Now what is the product? That is 2NOBr. This is slow step. Okay. This complex reaction. Okay, listen. Okay, sir. For in case of elementary reaction, now simple I am seeing the balance equation, I can write the rate expression, right? Sometimes for complex reaction also they give the experimental data also. I can use the experimental data. Okay, I'm going to compare the two rate equation. I can find out the order. Okay, suppose they give the complex reaction, then how can write the rate expression? Okay, please note in complex reaction, very important point. This is very important. Okay, this is EPOV. What is EPOV? Exam point of view. Please note in complex reaction. In complex reaction, end step on the slow step. The slow step, nothing but RDS. What does RDS mean? Rate determining step. Rate determining step. அப்ப அந்த ஸ்லோ ஸ்டெப்ல என்ன ரியாக்டன்ஸ் இருக்கோ அதை வச்சு I am going to write the rate law. Now see which is slow step, step 1 or step 2, what tell me which is slow step? Step 2, step 1 is the first step, step 2 slow step. Okay, now using the second step I am going to rate. How to write the rate? Simple, right? We have to put the rate that equal to K into NO BR2 and NO. Okay, this is a rate. Now we have to check. Okay, this okay wa? Again is a problem. Why problem? Na whenever we are writing rate expression, okay, or rate that rate law only involving reactant product. Okay, reactant okay, generally the people write the rate law using reactant. Okay, we can write the rate law using also product also. Okay, whenever we are going to write the rate law must having the stable substance. Okay, what is stable substance? Reactants. Okay, now see the rate law. What is reactant here? NOBR2. Now see the rate law. NOBR2. This NOBR2 is intermediate. Yes or no? Is intermediate. Upper rate law intermediate. Then how can change the intermediate to stable configuration? Now I'm going to approach the two. I'm going to apply the two approach. First one, steady state approximation, and second one, what? Equilibrium step. You got the point. What is the use of SSA? Or rate law intermediate. Okay, listen, rate law and the rate law is only contain stable species. Okay, stable species rate law. Suppose on the molecular stable species we have to change the concentration of stable intermediate to stable. Based on two law, one is equilibrium approach, one is SSA. Okay, now going to discuss one by one. Please know. First, what is SSA? That is steady state approximation. That is yes. Please note. The application very important. Okay, it state that the concentration of reactive intermediate. What is reactive intermediate other than reactant? Okay, reactant product. A reactive intermediate is constant. What meaning now? The change in the concentration of the change in the concentration of reactive intermediate with respect to time is equal to 0. That's meaning. Okay, you state that the concentration of reactive intermediate is constant in the reaction system. In the reaction system. Okay, therefore, okay, see the equation A gives B. Okay, B gives product. Which is intermediate? B is the intermediate. Therefore, changing intermediate concentration by dt that equal to 0. This is called okay, SSA. Answer now. How to write the SSA? Please note. Step 2, right? Step 2, write rate expression. Rate expression for complex reaction. For complex reaction. using slow step. Using slow step. What is slow step now? That is a rate determining. Okay. Step one. See. Step one. In a step now. Write the rate expression using slow step. First start writing the rate expression. Using slow step. Slow step. What is second step? Please note. If rate expression, very important, that's one point. If rate expression, okay, involved only stable species. Stable species are stable. Like example, or reactant product etc. Okay, suppose in the rate expression or reactive intermediate, we have to change the concentration of reactive intermediate to stable concentration using what? SSA. Third step. Please note. Suppose in case if the rate involve a reactive intermediate, okay, then we need to change its concentration in terms of stable species. Okay, for this one we are going to approach two approach. What is two approach now? The first approach, please note, that is called, okay, two approach. ரெண்டுமே simple தான், okay? Two approach. First one, equilibrium approach. ரொம்ப simple தான். This is equilibrium. கவனி, இதே எப்போ அப்ளை பண்ணோம் அப்படின்னா, இதே அப்ளை பண்ணோம்னா நமக்கு காம்ப்ளெக்ஸ் ஸ்டெப்ஸ் தருவாங்கல்ல, அந்த ஸ்டெப்ஸ்ல வந்து ஈக்குலிபிரியம் ஸ்டெப் ரொம்ப ஃபாஸ்ட் கொடுத்தாங்கன்னா we can write the direct equation. Okay, please understand. Please, okay, this approach we can use when the mechanism involve fast equilibrium. என்ன வரும்னது fast equilibrium step இருக்கு அப்படின்னா, fast equilibrium steps இருந்துச்சுன்னா நம்ம ஈஸியா யூஸ் பண்ணிடலாம். புரியுதா? we can find out the, okay, you can apply the equilibrium approach, find out the intermediate constant கண்டுபிடிச்சிடலாம். Second SSA, இது எப்படின்னா, SSA, it is used when there is no fast reaction, no fast equilibrium in mechanism. இதுக்கு we can use SSA. புரியுதா? Very simple. Okay, now see, I do one question for example. Okay, simple question discuss பண்ணலாம். Okay, அந்த question எடுக்குமே, மேல இருக்க question. இந்த questionல, okay, see, இதுல equilibrium இல்ல, ரைட்டா? அப்ப SSA அப்ளை பண்ணணும். இதுக்கு equilibrium வந்துச்சுன்னா நம்ம டைரக்டா அப்ளை பண்ணிடலாம். Okay, wait, I will see one question for a simple approach. The simple question. See, now see question number 1. For question, this is 2O3, 2 gives 3O2. This reaction. Okay, 3O2. This reaction. They give the steps. Steps 1 and O3 equilibrium. Okay, just wait. O3 equilibrium, that become O2 plus O. They given fast கொடுத்துறாங்க. Okay, they mentioned the question. Now what is in the step? O plus O3. This is, okay, this is K. Okay, now this is 2O2. This slow step. என்ன கொஸ்டின்னா write the rate law. Write the rate expression. Rate, write the rate, just wait. Rate expression. இது k equilibrium. Rate expression. எழுதலாமா? இப்போ இது ஸ்லோ ஸ்டெப், step 2 ஸ்லோ ஸ்டெப்பா? அப்ப அதை வச்சு ஃபர்ஸ்ட் ரேட் எழுதணுமா? Now what is the rate? Tell me anyone, students. Now what is the rate? Anyone? Rate that equal to, what is the equation ma? Rate. Anyone? Which is slow step? See the slow step, tell the reactant. That is the rate na? That is k is equal to O into O3. Now tell me, இந்த ரேட்ல எல்லாமே ஸ்டேபிள் அன்ஸ்டேபிள் ஸ்பீஷிஸ் இருக்கா? How to find unstable species? Overall reaction like reactants இருக்கணும். அப்ப இதுல unstable species, tell me. இதுல unstable species O3 ஆ students? Which unstable species? O na? Yes or no? Because reactant la O3 இருக்கா, therefore listen, therefore the concentration of O by dt is equal to 0. இது SS application, ஓகேவா? இப்போ என்ன டேட்டா என்ன பண்ணா, டேட்டா ஈக்லிபிரியம் ஃபாஸ்ட் கொடுத்துறானா, therefore I am going to approach. Okay, now see, ஈக்லிபிரியம் given ஃபாஸ்டா கொடுத்தனால I go with equilibrium approach. Now what is equilibrium? You know, product by reactant, therefore k equilibrium that equal to O2 by O by O3. Yes or no? Now what is the O value? We can just rearrange the formula na. Now what is the O value? That is O, nothing but k equilibrium O3 minus 1, okay, sorry, plus 1, O3 plus 1 and O2 minus 1. Okay, now just apply the O concentration to this equation, we get the rate law na. Now what is the final rate law? That is rate that equal to k into k equilibrium. Yes or no? K into k equilibrium, then O3 1 by O2 minus 1 and O3 1. Sir, no? 2 மாத்திக்கலாமா? 1 மொத்தமா? அப்ப இங்க O3 2. இதுதான் equation, rate equation. Okay. Now what is the order of reaction? Now what is the order? This is 2 minus 1. Therefore this is a first order reaction. First order reaction. புரியுதா? அப்ப அந்த ஈக்குவேஷன்ல வந்து, ஓகே, ஈக்குவேஷன்ல வந்து அந்த ஈக்லிபிரியம் ஃபாஸ்ட் கொடுத்தானா we go directly go with the what? ஈக்லிபிரியம் போயிடலாம். ஓகே, சப்போஸ் ஈக்குவேஷன்ல ஃபாஸ்டே கொடுக்கல அப்படினா, ஓகே, now see our question, first question, NOBR இருக்குல பாருங்க. இந்த ரியாக்ஷன் காம்ப்ளெக்ஸ், இது காம்ப்ளெக்ஸ் ரியாக்ஷன் தான். ஸ்டெப் 1 ஸ்டெப் 2. இதுல என்ன பண்ணாங்க, இதுல வந்து அவங்க என்ன பண்ணல, இதுல வந்து ஈக்லிபிரியமே இல்ல. அப்ப I go with SSA. சப்போஸ் the question ஈக்லிபிரியம் கொடுத்துட்டு அந்த ஈக்லிபிரியம் மென்ஷன் பண்ணாம இருந்தா கூட, ஓகே, சப்போஸ் ஈக்லிபிரியம் ஸ்லோ ஸ்டெப் இருந்தா கூட we go with SSA. புரியுதா? This is important, please note. Okay, please, very important, please note. Okay. Okay, I can do one question based on SSA. Please note the question. Question point, then go with the concept. Puritha? SSA approach. That is SSA approach. Just wait. Now see the reaction, that is A2, this is become 2A. This reaction, okay, this K dash. This is A plus B2. Wait, just wait. They can write A2. A plus B2 gives K1 C plus B. Now B plus A2 gives K2 C plus A. Okay, now question, apply SSA for A concentration. Apply. Okay, now see, very please note. இப்ப என்ன மீனிங்னா dA by dt is equal to 0 வா? இதுக்கு என்ன மீனிங், ப்ளீஸ்? ஓகே, this is called the rate of consumption of A. The rate of consumption. Rate of disappear. disappearance of A that equal to rate of appearance of A. இதான் மீனிங். appearance of A. இதான் SS அப்ளை பண்ணோம். இப்போ see இப்போ ஈக்குவேஷன் பாரு எங்கெல்லாம் வந்து A டிசைபர் ஆகுது பாருங்க. எந்த ஈக்குவேஷன்ல இந்த இப்போ இது ஈக்குவல் இது விட்டு ஓகே இது ஸ்டெப் 1. இது ஸ்டெப் 2 பாருங்களா. ஸ்டெப் 1ல A plus B2 gives C plus B. அப்போ வந்து ஃபர்ஸ்ட் ஸ்டெப்ல வந்து A டிசைபர் ஆகுதா? எஸ் ஆர் நோ? செகண்ட் ஸ்டெப் A ஃபார்ம் ஆகுது. அப்போ what is rate of disappearance? now write the formula. now what is இது K1 ஆ? அப்ப K1 into okay, just write. K1 into A sir no plus yeah K1 into A and BR2 yes or no BR2 okay what is the rate of appearance of A idu appa K2 into B by A2. You got the point. Now what is concentration of A? You can find out now. Therefore what is concentration of A? Nothing but K2 by K1 okay B into A2 by BR2 கண்டுபிடிச்சோம் அவ்வளவுதான். எஸ் ஆர் நோ? இதான் கான்சன்ட்ரேஷன் ஆஃப் A. புரியுதா? இது we can apply the formula. புரியுதா? அப்ப நம்ம என்ன ஸ்பீஷிஸ்க்கு வந்து SS எடுக்குமோ அது என்ன ஃபார்முலா? the rate of appearance of that species equal to rate of disable of that species. அது வச்சு we can find out the intermediate concentration using SSA. இது SSA. புரியுதா? very simple. Please know. But this use many reactors. For example, enzyme kinetics mechanism. Okay, today we are going to discuss. Okay, that topic we have to apply SSA only. We can find out the active intermediate concentration enzyme. Similarly, on the unimolecular Lindemann reaction. Okay, a Eyring equation, ART theory. Okay, ART theory. That theory is only involving what? SSA only because most of reaction. The most of reaction in generally are complex reaction. Okay, only few reactions are elementary. Now watching எல்லா reaction வந்து mostly complex reaction தான். அப்ப for complex reactionல கண்டிப்பா நாம rate ல involving ஒரு intermediate step வரும். அப்ப we have to change intermediate, we have to apply the SSA. Okay, this is a very important topic in our exam point of view. Please note. But by luck வந்து क्वेश्चनல வந்து நமக்கு வந்து slow fast step equilibrium கொடுத்தானா data equilibrium போயிடலாம். Okay, அப்படி கொடுக்கலனா SSA போயிடணும். ஓகேவா? Now this is homework for you. You just try this question. Okay, now homework. This equation O3 equilibrium K1 K2 O2 plus O plus O3 so gives K. இது K1 இது K inverse எடுத்துக்கோ. ஓகேவா? இது K inverse இது K2 இங்க 2O2 இது ஸ்லோ ஸ்டெப். அப்ப வந்து இந்த ஈக்குவேஷன்ல ஃபாஸ்ட் ஸ்டெப் கொடுக்கல அப்ப we can apply SSA. புரியுதா? இப்ப கிளாஸ் கட் ஆயிடும். You can join the same link. Okay, because Zoom 40 minutes are free. After ending the class you can join the same link. We continue the class. Okay, இது ஸ்லோ ஸ்டெப். what is rate apna? Rate that equal to K into O plus O3. ரைட்டா? இது O plus O into O3. அப்ப எது இதுல இன்டர்மீடியட் O வா? அப்ப for dO by dt you have to apply what? You have to apply SSA apply பண்ணுங்க. கண்டுபிடிங்க. Okay, this is homework. You just do this question, send the answer to WhatsApp group. ஓகேவா? next I'm going to suppose equilibrium fast கொடுத்தானு வெச்சு டேட்டா போயிடலாம் क्वेश्चनக்கு. ஓகே, அவங்க ஃபாஸ்ட் கொடுக்கல, அதனால we go with SSA. by luck அவங்க ஃபாஸ்ட் கொடுத்தானே very simple question தான். just apply the equilibrium the K1 by K inverse is equal to அதை வெச்சு நம்ம O கண்டுபிடிச்சிடலாம். ஓகே, இந்த क्वेश्चन நீங்க வந்து ஈக்குலிபிரியம் ஃபாஸ்ட் வச்சு சால்வ் பண்ணுங்க. ஃபாஸ்ட் இல்லாம சால்வ் பண்ணுங்க. we get 2 rate law. ஓகேவா? அதோட அப்ளிகேஷன்ஸ் பேசாத. ப்ளீஸ் மியூட் யுவர் மைக். பேசாத கிளாஸ். ஓகேமா, we'll see. இந்த கிளாஸ் எடுத்த ஒன்லயே பேசாதன்னு சொல்லிட்டேன். ஓகே, ப்ளீஸ் மியூட் யுவர் மைக். This topic very important. Okay, Damn sure the question will come for TRB exam. That is enzyme catalyst. That is called Michael Menton equation. Okay, please note. Now please mute your mic. Please note. That is enzyme catalyst. In the name of Michael's Menton equation. Okay. Surely theory or numerical based question or graphical based question. Okay. Now for this topic, there will be many chance to ask graphical based question based on graph, based on slope and intercept. They will ask numerical problems. Okay. The direct formula also they will ask. Okay. Let's start the topic. Now please note. Now what is the enzyme mechanism? I will teach basic one. Please note. Enzyme possesses finite number of active site. Finite number of active sites. Now, see, second point. The substrate interact with enzyme. Through active site. Through this active site. To form active complex. To form enzyme substrate complex, that is ES complex. Okay, please note ES complex. Please note. Now see the mechanism. Okay, next point, please note, very important. Enzyme complex can revert back to form substrate. Okay, and the enzyme ES complex and the ES complex can convert product. Now see the reaction, please note, very important. So what is the final equation? What is the reaction mean? Now see the reaction. Enzyme plus substrate. Enzyme plus substrate is equilibrium. That is K1. It's a K inverse. That is activated complex, ES. Now this ES activated enzyme complex convert to product, that is K2 product. Okay, now see, this is a slow step. It's not slow step. Okay, now how to write the rate expression? Listen, using slow step, we can write the rate expression, and therefore the rate that equal to K into ES. It's a rate. Now you know very well, right? The rate expression don't containing active complex. By the energy ES active complex. We have to apply SSA for the active complex, SSA for the ES. Okay. Before going to SSA, I will teach some point. Please note. What is E abina? What is E abina? Concentration of free active site. Okay. That is concentration of free active sites at time t. What is ES? The meaning of it, no? That is concentration of occupied sites at time t. Now, what is E naught? We know, right? What is E naught? Nothing but initial concentration. Initial concentration of free active site. Free active site. Okay. Now, what is the form? Now, what is E naught up now? Okay, initial concentration that equal to, okay, E plus ES. E plus ES. Okay. Now, this is very important relation. Please, this is very important relation. Listen. Okay, very, very important. Note panninga, ரொம்ப important. Okay. Now, we write the rate law. Using rate law, I'm going to find out the active intermediate concentration using SSA, right? Now, what is rate law? Simple. Now, a rate is equal to K2 into S. இதான்ல. இப்போ I'm going to apply SSA. Okay. For apply SSA for ES. இது என்ன மீனிங் அப்ப the rate of appearance of appearance of ES that equal to the rate of this one, rate of disappearance, rate of disappearance of ES. புரியுதா? அப்ளை பண்ணலாமா? Now see the what is the equation, okay? Got it. Just wait. என்ன formula? First write the equation first. என்ன equation? E plus X. இது equation E plus S. இது K1. இது K inverse. இங்க enzyme catalyst. Right or இல்லையா? Now ES to gives K2, that is product. Well, the rate of appearance is first K1 appearance அப்ப the K1, okay. CSS apply பண்ணலாம். K1 into enzyme subtract. இது appearance இப்போ எது disturbance K inverse disturbance அப்ப equal to K inverse disturbance அப்ப ES வந்து S plus E அப்ப K inverse, that is K inverse யும் இங்க சரி K inverse reactant ES தானே இப்ப reverseல பார்த்தா இங்க ES அதே மாதிரி plus K2 ES. Yes or no? ES வெளியே எடுத்துடலாமா? Therefore, okay. Listen. Now, what is E? Now, see. What apply the formula? What is the formula? E naught is equal to E plus ES. Yes or no? Therefore, what is E is equal to? E is equal to E naught minus ES. Just apply this one to equation. In the equation, apply பண்ணலாம் equation ல. apply பண்ண ஒரு அப்பனா apply பண்ணீங்கன்னா that is K1. Nothing but what? E naught minus ES close the bracket and ES. Yes or no? That equal to K1 into ES plus K2 into ES. Now just multiply the equation. Multiply பண்ணீங்க அப்படின்னா K1 E naught, okay, yes, minus K1 ES into S. That equal to K1 into ES plus K2 into ES. Right or yeah? Now see, this is going to be lama ES. Appa inga K1 inga E naught into S, that equal to K1 ES plus K2 ES plus K1. This K inverse la. This K inverse. This K inverse na. Sorry. This K inverse. This K inverse. This K inverse. Okay, just wait now. I will change. Okay, the K inverse no na. Please, the K inverse. This is K inverse. K inverse. This also K inverse. This is K inverse. Okay. Plus K1 into ES into S. இப்போ the ES காமன் வெளியே எடுத்துலாமா இந்த ஈக்குவேஷன்ல? now K1 into E naught into subtract S, that equal to ES காமன் வெளியே எடுத்துட்டீங்க அப்ப என்ன வரும் ஈக்குவேஷன்ல? K inverse plus K2 plus K1 subtract S. Yes or no? Now what is ES? What is ES concentration? That is ES equal to K1 E naught into S divided by K inverse plus K naught K1S plus K2. Right? This and the active species concentration. Okay. I just apply SSA. I find out what the active intermediate concentration. Now apply this. Now I'm going to apply this concentration to the rate law. Now what is rate law? You know very well. What is the rate law? We write already. What is rate law? See, rate. The rate is equal to okay. K1 K2 rate. K2 K2 into ES. ES substitute ES either. What is the final equation? That is a rate. Very okay rate. That is a rate is equal to K2. Okay. What is the equation? K1 K1 into E naught subtract by K inverse plus K1 yes plus K2. This is the rate equation for enzyme catalyst equation. Very important. Okay. I'm going to derive different form of this equation. Okay. Now see, I will tell what is Km. That is called Michaelis-Menton constant. Okay. That meaning now that is K inverse plus K2 by K1. That is called Km. Appa idhula K inverse. See, this update ulta panna equation. Okay. Ulta panna equation. Now see, just wait. Okay. I can derive this equation. Now see. இந்த ஈக்குவேஷன் இருக்கா இதை சேஞ்ச் பண்ண போறேன் எப்படின்னா ரேட் தட் ஈக்குவல் டு ஓகே லிசன் என்ன பண்ணா மேலே கீழே K1 டிவைட் பண்ணுவோம் K1 டிவைட் பண்ணீங்க அப்படின்னா K2 K1 டிவைட் ஆயிருமா அப்ப E நாட் ES by okay K inverse plus K inverse plus K2 into K1 plus inga enzyme. One enam with that. We are going to divide K1. Divide பண்ண மேல எங்க பண்ணா இங்க K1 S K1 கேன்சல் ஆயிடுமா அப்ப K inverse plus K1 இது एक्चुअली பார்த்தா K inverse by K1 K2 by K1 காமனா K inverse plus K2 by K1 இது K1 by KS by K1 into S by K1 னா K1 கேன்சலா ஓகே அப்ப என்ன ஆயிரும் ஈக்குவேஷன் ஃபார்ம் ஆயிடுமா இதான் ஃபார்ம் இது ஷார்ட்டா எழுதலாமா what is short form னா the K inverse plus K2 by K1 is equal to Km. Now what is the formula? That is the rate that equal to K2 into E naught into S into by Km into S. This is a formula for other form of Michaelis-Menton equation. Now I go into one more form. See, this is first equation, this is second equation. Now what is other form? Please note, very important. Rate R max. What is R max now? Okay, maximum. Listen, what is R max now? Maximum rate. What is maximum rate now? The maximum enzyme substrate going to occupy the free active size of enzyme. That is called R max. Okay, actually என்ன சொல்லுவாங்கன்னா most probable speed சொல்லுவாங்கல்ல நம்ம ஆரம்பத்துல சொல்ல ஓகே most probable speed இல்ல அந்த மாதிரி most probable னா அந்த ஸ்பீட்ல வந்து ஆல் மாலிகுல் அண்டர் கொலிஷன் அதே மாதிரி what is RMS அப்படினா அந்த டைம்ல the most of enzyme active site free site going to occupied by substrate. That is called R max. What is R max now? That is R max. Generally that equal to very important formula that is K2 into EX. This is R max EX. Okay, very important. Now what is R max? I give you the definition. Please note. When all sites are occupied. When all sites are occupied. Okay, then R is equal to R max. Okay. Now what is the formula? See, this is the formula. Up in the K2 in ES now. Okay. Now see. Now you know right. Listen. Now in the case when R is equal to R max that ES that equal to E naught. Yeah, E naught na எல்லாமே ஆக்குபை ஆகணும்ல அப்ப E naught ES மாத்திக்கலாம் ரைட்டா இல்லையா yes or no therefore okay therefore R max equal to K2 into E naught அவ்வளவுதான் இது அப்படியே அப்ளை பண்ண அப்ப இந்த டேர்ம் இந்த what is K2 into E naught This equal to R max. Now, what is the formula? Please write the formula. That is direct formula. That is a rate. That is a rate that equal to R max into subtract by Km into S. In a formula. Is it that formula for Michaelis-Menton equation? It's very important. Now I am going to discuss about what is Km. What is a factor of Km? Okay. The unit of Km. This is moon topic ma. One equation there, you know. What is unit of Km there, you know. What is turnover number there, you know. What is catalytic efficiency? That's the graph work. Okay. Now see. Please note Michaelis-Menton constant. That is Km. Michaelis-Menton constant. That is called Km. Okay. What is the formula? That is Km that equal to K inverse plus K2 by K2. Okay, this is K2. K2 by K1 in the formula. Note the characteristics of Km. This one. First, it represent how efficiency of enzyme. How efficiently an enzyme bind with substrate. Substrate. Okay. Now see, very important point. Lower the value of Km. Lower the value of Km, higher the binding efficiency. Higher is the binding efficient binding affinity. Okay, binding affinity. Okay, very important. Okay, this is a most probably the question asked. Okay, theory part. So lower the value of Michaelis-Menton constant, higher will be the affinity of enzyme to bind to active site. Okay. Now what is the unit? Very simple, ma. Km that equal to K inverse plus K by K2 by K. This full cancel K. What is the unit of now? Mole per liter. Please, mole per liter. You can just learn directly this. Okay, mole per liter. Okay. Next very important topic, turnover number. What is turnover number? This is very important from exam point of view. Next topic under the category turnover number. That is turnover number. That is called TON. Okay, or turnover frequency. Turnover frequency. Okay, direct formula. Okay, simple formula. Okay, first I give the definition. Okay, because TRB la most they will ask theory questions. Now we have to know the definition because the definition based question came. Okay, that time without definition we know the formula. There is no useless, right? Therefore, I go and give the definition for you. Please note the number of molecules. What is TNO? The number of molecules. The number of molecules. Okay, of substrate converted by one moles of catalyst by 1 moles of catalyst per unit time is called TON. அப்போ 1 mole catalyst வந்து or 1 molecule catalyst வந்து ஓகே எவ்வளவு நம்பர் ஆஃப் சப்ஸ்ட்ராக்ட் வந்து கன்வெர்ட் பண்ணது ப்ராடக்ட்டா அதான் அது. ஓகே that is called TN. okay, turnover number. ஓகேவா? Now what is the formula? This is important. The TON depends upon temperature. Now see the formula, very important. That is turnover number that equal to K2. Direct formula. எப்படி R max equal to okay K2 in E naught அதே மாதிரி what is current one number that is equal to K2. And last important topic in this category, catalyst efficiency, that is called kinetic efficiency. Okay, now see the equation. Please note. Please note. Third important for this topic, that is called catalytic efficiency. That is catalytic efficiency or kinetic efficiency or kinetic efficiency. Please note. A simple one. Write the definition again. It is a measurement of how sensitivity on enzyme convert to substrate to product. Okay. Please note this sentence. Okay. It is the measurement of measurement of how efficiently an enzyme converted substrate to product. Direct formula, the catalytic efficiency that equal to K2 by Km. What is the formula? Wait, I will write properly. K2 by Km. Please note. Direct formula K2 by Km. Okay, important, please note. Okay. Now see the cases, very important cases. Okay. Now what is the formula? General formula, that is a rate that equal to K2 into E naught into subtract by okay Km plus yes. Okay. Now case one. Please note the case. Very important. Okay. Case one important question. That is case one. Case one now. If the Km less than initial concentration. What is the rate? That is a rate is equal to K2 into E naught subtract by cancel. Therefore, a rate that equal to K2 into E naught. Now you know what is K2 into E naught? R max. Therefore, in this case, the rate that equal to R max. My number question when rate equal to R max. First option, okay. The concentration of substrate very less than Km. Second option, the concentration of substrate is greater than Km. Okay. Third option, the concentration of the value of Km and concentration both are same. Okay. That fourth option, the Km value very higher than Ks. Okay, very higher than substrate. Okay. What same or when the concentration of substrate is very larger than Km value, that case R max that equal to rate. Sorry, rate equal to R max. The first case or second case. Please case 2. Case. Either if K max Km that equal to SR now. Now what is the formula? Derive same. What is the equation? Now rate is equal to K2 into E naught subtract by Km plus SR. But Km is equal to SR. Now when I formula K2 into E naught subtract by 2 subtract cancel. Therefore, the rate that equal to K2 into E naught by just wait. Just wait now. Wait, I'm correct, right? Yes, correct. Everything should be correct. K2 into E naught by 2. Yes or no? Now what is K2 in R max? Therefore, this is equal to R max by second one. எப்போ ஆல்மோஸ்ட் ரெண்டு சேமா இருக்கும் அப்படின்னா எஸ் அதிகமா இருக்கும். எப்போ எப்போ பை 2 டைம்ஸ் இருக்கும்னா ரெண்டு சேமா இருக்கும். புரியுதா? இதான் தேர்ட் கேஸ். கே அதிகமா என்ன ஆகும்? கேஸ் 3. கேஸ் 3 that is km very greater than substrate. Sorry, very greater than substrate. அப்ப என்ன ஃபார்முலா வரும்? Substrate. Very simple na. It means substrate low concentration. This low concentration. Meaning என்ன இதுக்கு வந்து substrate high, this high concentration. High இருந்துச்சுனா புரியுதா? Sometimes they will give theory கொடுத்தா மாட்டிப்போம்ல, அதுக்காக. ஓகேவா? Now what is the formula we can derive? Simple. That is rate that equal to K2 into E naught by S by Km into substrate. இது போயிடுமா? இது அப்ளை பண்ண அப்ப what is the final equation? இதான் equation. புரியுதா? Out. Important, please note. This about today class. Next week I am going to continue again chemical kinetics. Okay. Next week I will complete the chemical kinetics lesson. Next week I will discuss some graphic representation of enzyme catalyst mechanism. Then followed by ART theory and collision theory and Eyring equation, and end with the problems. Okay. Now I give the 2 minutes, 5 minutes time. You can ask your doubts. Next week I will finish the kinetics lesson. Then go with the next lesson as per your wish. Okay. Any doubt? Let me ask one by one. I am telling damn sure this note for sufficient for till our CSR exam. Okay, you are preparing for CSR level. Okay, this concept is enough. But what we are going to do? Suppose you are going to prepare for CSR gate level, in the concept is more than efficient. Okay, but what is the difference between TRB and the CSR gate up now? For TRB, CSR, okay, so CSR and gate, you have to do number of numerical problems. Okay, for TRB, less numerical, more conceptual. புரியுதா? ஒரு கான்செப்ட் படிச்சு அப்ளை பண்ணி கம்ப்ளீட்டா அப்ளை பண்ணி நியூமெரிக்கல் பார்ட்டா போயிடுச்சுன்னா அது சிஎஸ்ஆர் கேட் லெவல். ஓகே, அந்த கான்செப்ட் இன் டெப்தா அந்த கான்செப்ட் என்ன சொல்ல வருதுன்னு சொல்லிட்டு நீங்க புரிஞ்சுக்கிங்க அப்படின்னா அது டிஆர்பி எக்ஸாம். இட்ஸ் a minor difference. புரியுதா? Any doubt, students? No. Okay, ma. Thank you so much for listening the class, and see you next week as soon as possible, and take care and tata bye bye.